So this is, okay, so we're back. We're doing the stats project. We have part 2 we're working on right now, okay? So this is part 2, and with part 2, we are gonna be using, oh man, this screen's all over the place, one sec. We are going to be using the data from our Excel sheet, and this is the data that I have. So I have, the student, I have, this is the hours of sleep, right? And, I'm gonna pause this and just get all this written out. So let me just pause the video. So now we have the data here already for us. And we're looking at these students. They have a certain number of hours of sleep and a GPA that corresponds. And we're trying to figure out, is there a correlation? Actually, we're just trying to get an idea of what's going on with this data. Correlations are going to be part 3. Part 2 is just getting this data onto a scatter plot, graph the line of best fit, which they give us the line of best fit. They said the line of best fit was y is equal to 0.1x plus 3. This 0.1x, if you understand this, it's awesome. If you don't, no worries. This 0.1x is also, you could see it as x over 10. 1/10 of x, right? 1/10 of x. So you can write it either way. It won't really make a difference because we'll use our calculator for that part. But this is our best fit line that is given in the Excel sheet, each option. And right now I should tell you as well, there were 2 options, and this one is doing option 2. It's comparing sleep and GPA. So I'm looking at this, and the first step is to make a scatter plot, and I have to do that right below it. And you know what? This is what I'm gonna do. This is what I suggest. We're gonna put our residual plot below this. So go ahead and just make your scatter plot a little bit smaller than usual. See how I left some room below it? That's where we're gonna put our residual plot. So I'm just gonna plot these values, and what I'm doing, you can always assume that we are going to be comparing X and Y. And I just set it up for you like that. Yeah, if you're still working on part 1, the video is going to be super helpful. And Monday will also be a day that we'll look over part 1 and part 2, okay? All right. So here we go. Let's plot some of these guys. We are doing this on hours of sleep, and we're doing this as GPA. Okay. So let's see. 9 hours of sleep. I better look and first make my my range here. It's only up to 9 hours, so I'm just going to do it 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm just going to do it straight. And GPA, it's between 3, 8, and 4, or 3, 5, and 4. So I'm going to do a little warp right here. I'm going to do a little warp, and I'm going to make this. Let's see. How about this? 3.0. 3.1, 3.2, 3.3, 4, 5, 6, 7, 8, 9, 4.0. Okay. So that sets up the graph. And I didn't do it here, but really my range, and I could have even warped up to 3.4. I could have started 3.5 here. It is your choice on how you set up your graph, as long as all the data fits and it doesn't go way off the graph. That's really what's helpful. So let's go ahead and graph these one at a time. We have 9 hours of sleep, got a 3.8. 9 hours of sleep, 3.8. 7.5 hours of sleep, got a 3.8, 7.5. 5 hours of sleep, got a 3.5, 5 hours, 3.5. 7 hours of sleep, in this case, got us a 4.0. 5.5 hours of sleep, got us a 4.0. 8 hours of sleep, 4.0. 7 hours of sleep, we got another one, 4.0. So I'm going to just put that still on the same point. We had a duplicity here. These are the same values. So when that happens, you can only put one point there. Just know that that's fine. We got it. Okay. So that was step 1. We had to make our scatter plot. Okay. Okay. Now, with this, we now have to graph the line of best fit. The line of best fit is given for these problems. I'm not doing problems that make you find the line of best fit. That'll be in the unit test, but not for this activity. Okay. And with this line of best fit, let's go ahead and graph it. So let's see. It is the best fit. It's from 3. So actually, it's good that I put 3 right here. Huh? It's good I put 3. And if you didn't notice that, you might have to come back and adjust it, like or take an estimate of where 3 would be located. There's a few things you could do. Okay, but hopefully, following my example here, giving a little bit of room, checking the best fit line. Where is that y-intercept going to be? Because remember, we're just looking at, this is our b value, y-intercept, and this is our slope. Okay. So we're here at 3. And what do we need to do? What's the rise over the run? The rise is 0.1, the run is 1. Whoops, can't see it. The rise is 0.1, the run is 1. So watch, it's going up 1, or sorry, up 0.1 over 1. Up 0.1 over 1, and so on. It's going to go right through the points. So, you know, if you would have done your graph different, your graph, if your unit's different, your graph might look different than mine. That's fine. That's fine. Okay. So we have our line of best fit. That's this. Number 2 was line of best fit, right? Number 2, line of best fit. Okay. And then we need to use a table to find the residuals. Now, Ahmed, look, I had defined each line as 0.1, right? From 3 to 3.1 is up 0.1. If it was 3 to 4, yeah, I would go up like a tenth and then go over and up a tenth and over. But look how I define my y-axis. 3, 3.1, 3.2, 3.3, 3.4, right? So if I'm going up 0.1, I'm going to go up from 3 up to 3.1 and then over 1. Up to 3.2 and over 1. Yeah, you weren't the only one. I'm sure others thought that. Thanks for bringing it up. Okay, this is how we're going to set up our residual plot. And I see that I have to kind of clean up my paper a little bit because my goal was, and when you get to working on this on your actual paper, you know, it's going to be helpful to keep it, right? To keep it where you can have the best fit line as part of the table, okay? So keep that in mind. Everybody get caught up to that point. And remember, this is how it works. We are looking at how many hours of sleep and how many what the GPA should be. Okay, so we want to think of this as this. This right here is the actual. Remember we were talking about this? That's the actual. The line of best fit is saying, based on the number of hours you sleep, the line of best fit is saying the projected GPA should be connected to the line of, the projected is the line of best fit. So the line of best fit is saying what it should be, and the residual is subtracting those two things, and that's going to be our residual. We'll do this in a sec here. So we're getting our residuals right here. Now, what is a residual again? A residual is saying that, look, at, let's see, at 5.5 hours of sleep, right? At 5.5 hours of sleep, I got a 4.0, but based on the line of best fit, right? 5.5 hours of sleep should have given me 3.55, right? So the residual is, remember, how far up or how far down the point is from the line of best fit. You see? So we're figuring out those residuals. And what we're doing, how we're doing it is, we're going to plug in the hours of sleep into the best fit line, and then subtract it from the GPA that you actually got. That's going to show you how far off you are. You're projected, how far off the actual is from the projected. So let's do it. Y is equal to 0.1 times 9 plus 3. And what does that give us? 3.9. What does that give us? 9 times 0.1 equals plus 3. Yeah. 3.9. Yeah. That makes sense because look, at 9 hours, look where the line is. 9 hours, it's at 3.9. So that makes sense. The line, the best fit line is just what the projected. Now, did that person that sleeps 9 hours get 3.9? No, they got 3.8. And when we subtract these, 3.8 minus 3.9, we're going to get that -1 as our residual because it's -0.1 because it's 0.1 below. Okay. Let's do them for all of them, then we'll subtract them. Y is equal to 0.1 times 7.5 plus 3. This is going to be 3.75. Y is equal to 0.1 times 5. Remember, we're just plugging in the hours of sleep to see what the GPA should be based on how much you sleep. That'd be 3.5. That was right on the money. Y is equal to 0.1 times 7 plus 3. It's going to be 3.7. Y is equal to 0.1 times 5.5 plus 3. That's going to be 3.55. Y is equal to 0.1 times 8 plus 3, 3.8. And this one was the same as that one. 0.1 times 7 plus 3, 3.7. Woo! Residual plots. All right, look. We have now our projected GPAs and our actual GPAs. And what we're going to do is subtract them. We're going to subtract them. So let's see. 3.8 minus 3.9 is negative 0.1. I know, it's incredible. It's wild. 3.8 minus 3.75 is 0.05, 5 cents. $3.50 minus $3.50 is 0. We got one right on the money. 4 minus 3.7, 0.3. 4 minus 3.55, 0.45. 4 minus 3.8, 0.2. 4 minus 3.7, 0.3. That's the residuals. Yes, it is, indeed. Okay, so the last step, this was number 3. This was number 3 to find the residuals. And now number 4, we need to zoom out a little bit because number 4, it's going to be helpful to do our residual plot down here. This is our residual plot. Okay. And I like to do it right below it because when I look at this, I'm like, okay, if I make the y-axis exactly aligned up with the other, I can see in real time what is happening with my graphs. Okay, and I'm going to do the same thing. Hours of sleep, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then I'm going to go ahead and do, looking at my range of residual, I know that it goes from being -1 or 0.1 all the way up. The positive side is 0.45. So if I make these just like above, 0.1, 0.2, 0.3, 0.4, 0.5, I should be able to fit everything. Do the negatives here. Okay. So now what we're doing is we're taking these residuals and we're putting them into the chart. Let's do them one at a time. Let's see. 9 hours of sleep. 9 hours of sleep. My GPA was 3.8. I should have had a GPA of 3.9. So at 9 hours, it should be a -0.1. At 9 hours, -0.1. All right. 7.5 hours of sleep, I had a 3.8. I should have had a 3.75. So look, the residual at 7.5 hours is positive 0.05. At 7.5 hours, it's positive 0.05. Whew. All right, let's see. At 5 hours, I had a 3.5. It says that I should have 3.5. So at 5 hours, I was right on the money. 7 hours, I had a 4.0. It said I should have 3.7. So I was above the projected by 0.3. So at 7, I have to go up to 0.3. Nice. Color coding always helps. Let's see. At 5.5 hours, I had a 4.0. I should have had a 3.55. So I was above the projected by 0.45. So at 5.5, I'm going to go up 0.45. This person is like someone that doesn't need sleep and does awesome. Okay, where was I? At 8 hours, I had a 4.0. My best fit said I should have had a 3.0 or 3.8. So I was above the estimate by 0.2. So at 8 hours, I'm going to go up 0.2. Lastly, 7 hours, I had a 4.0. It said I should have a 3.7. So I was above the estimate 0.3. So this student number 7, 7 hours here, right? They were above at 0.3. So 7 hours, I go at 0.3, and that's a redundant point there because two people had the same amount. It's fine. It's just saying how far each point is off. So that is fine that there's some redundancies. All right, number 5. Is it a good best fit? Let's see. Let's see. So the biggest. So also I want to point out. Look at this. Because I lined these up. Look where this point is. It's right on the line. So the point right on the line is at 5 hours, and look at 5 hours. It's right on the line, right? At 5.5 hours, it was above this value. It was above this amount. And look, at 5.5, it's above this amount. The residual plot, yeah, I would say that too. It's all right. Look, at 7 hours, I was above 0.3. And look at 7 hours, it shows it's above 0.3. 7.5, a little bit above. Look on the plot. Yep, it was a little bit above. At 8, it was 2 above. At 8, 0.2 above. 9, it was a little below. 9, a little below. So the residual plot just shows you how far each of these points are off of the best fit line so that we can assess if it's a good fit. Now remember, you want to look, how far is it off? It's off by 0.4, but we always have to compare it to the scatter plot and look at the range here. Because remember, if the residual plot was off by 1, say if it was just off by 1, but my scatter plot was 0 to 1,000,000, if I'm counting up to 1,000,000, is it okay to be off by 1? Yeah, it's okay to be off by 1. So I want to look here. This is 0.1, 0.2, 0.3, 0.4, right? And up here, these also go up 0.1, 0.2, 0.3, 0.4, right? So these y-axes are actually approximately the same increment, 0.1, 0.2. It all goes up by 0.1. So I would say actually this, good fit, well, there's a lot of, for this amount of data points, right? Because I only went to student 7. For this group of students, I would say this is a moderate fit. Moderate fit because most data is above the line of best fit. I'm never going to use orange again. That's like the worst color. Orange. Yes, orange. I hate orange. Okay, guys. This is what you have to accomplish today. It has more data points. Yeah, I don't like yellow either. It has more data points than this, but I want you to give me a hint in the chat. On a scale from 1 to 5, how do you feel about accomplishing this? Nice. 5, 5, 4.5, 5, 5, 5, 4.5. Everybody, 5, 4.5. You guys are awesome. 4-ish. Okay. I think that, remembering what you're doing here. And this is a 20-minute video, so you can fast forward it. Remember, you can watch these YouTube videos on double speed. So I'm going to stop the video, actually.